Algebra 2, 2-7, parent functions and transformations. Parent functions and transformations. So let's talk about what a parent graph is. What is a parent graph? Parent graph is the simplest graph in a family of graphs. So let's look at what some parent graphs might look like, or we can also say parent functions. So parent functions. Let's look at a few different functions. So we're going to look at a constant function. And this one, if I were to draw a coordinate plane, put some random dots on here so you know I'm talking about that this is a coordinate plane. If I were to say draw a line that goes through here like that, that's parallel with the x-axis, this might be y equals 3. And the function might look like this, f of x equals a. So this, it would be f of x equals 3, right? But f of x equals a equals any number. Okay, so there's the parent graph of a constant function. Let's see what an identity function looks like. I'm going to draw my graph, my coordinate plane, and then I draw a line that goes through the x-axis at a x and y-axis through the origin at a 45-degree angle, and this is the line y equals x, or f of x equals x. Y equals x, f of x and y we use interchangeably. That means that all coordinates all coordinates are the same. They are equal. So if this was 6, then this would be 6. If this was 8, this would be 8. And this is a linear function. Okay, we got 2 more, and then we're going to start looking at some translations. Absolute value function. And if I were to draw my coordinate plane, and I were to draw a line coming down right here to the origin, and then I draw it coming right back up as if the y-axis was a mirror to it. This is y equals the absolute value of x, and f of x equals the absolute value of x. One more. Quadratic function. This looks like this. Kind of a big U shape. Y equals x squared. F of x equals x squared. All right, so here are some samples of parent functions. These are not all of the parent functions, but these are some examples of parent functions, some very common ones that we'll see in class. Now let's look at what translation does. So this is something that we're going to take this translation. This takes the parent graph and it moves it. It moves the graph, or it moves the figure. And we learned about this in Algebra 1 and also in geometry. Translation takes the graph and just moves it. Takes a function, just moves it. So here's an example. Y equals the absolute value of x plus 2. So my parent graph is, parent graph is y equals absolute value of x. So when we want to graph this based on this translation here, we can say, here's my parent. We just do the dotted line for the parent. Y equals the absolute value of x, which is that one right there. And this plus 2, notice how it's not inside the absolute value sign, it's outside. So that moves this whole thing up 1, 2. So it looks exactly the same. It just got moved up 2. So this is the absolute value of x, and then this one up here is the absolute value of x plus 2. It's important that we see that the plus 2 is outside of the absolute value sign. Let's look at one where the translation is inside. So let's look at this one. Y equals the absolute value of x plus 3. Now, when you've got the number next to the x value like this, you do the opposite of what you think you should do. So this says plus 3. Remember, plus 2 moved it up 2. If it was minus 2, it would move it down 2. Now, if it is inside this absolute value sign, next to the x, you do the opposite of what you think you should do. So this, you think you should move it to the right 3, but really you need to move it to the left 3. So here is my parent, and I move it to the left 1, 2, 3, and I have graphed my absolute value translation there. Now let's look at, let's have you do one. Graph, based on this translation, y equals x squared minus 4. So based on what we've just learned, we've got x squared minus 4. Find the parent graph, and then do what you think you should to it, to what this minus 4 is doing in the translation. Okay, go ahead and pause and do that work. All right, I'm going to draw a coordinate plane, and my parent is y equals x squared. That's my parent, and so y equals x squared is right here, so it's just kind of this big U shape. And since this is outside of what's happening to the x, then this is going to be, this is going to move my graph up or down. And since it's negative, it's going to move it down. 1, 2, 3, 4. Boop. And I've done that. Now, if you were to move it left or right, it would need to look something like this. Y equals x plus 4 or minus 4 squared. That would move it left or right. Okay, let's keep going. A reflection. A reflection flips a figure in or over the line of reflection. So a reflection, this flips the figure over the line of reflection. So let's see what an example of this might look like. Y equals negative x squared. So since this negative is happening outside of whatever is happening to the x, this is going to flip it over the x-axis. Or I'm sorry, did I say x? Yes, x. So my parent is y equals x squared. And I just flip this over the x-axis. And then I'm done. Let's do another example. Y equals x, negative x inside the parentheses squared. So now I've got the squared inside going on with whatever's happening to the x. So I'm going to have my parent graph. Oops, should be dotted. Now, since this one is inside here, this flips over the y-axis, or flips on. You'll see flips in, flips over feels better to me, but it's probably not actually quite accurate. Y-axis. Okay, so if this flips over the y-axis, this is already symmetrical across the y-axis. So that means that the final graph here just maps right on top of the parent graph, because it just flips over the y-axis. Let's have you try one. Y equals negative absolute value of x. So go ahead and pause and see if you can map this one out. All right, let's see how you did. I've got my coordinate plane. I got my parent, which is y equals absolute value of x. So there's my parent. Y equals absolute value of x. This negative that's outside of what's happening to the x means that I'm going to flip it over the x-axis. So that means there is my graph. Next, dilation. Dilation, oh, I shouldn't have written that sideways, but okay. Dilation squishes, squashes, scales. Okay, let's see what that looks like. Example, y equals 4x. So if I have my coordinate plane, if my parent of this graph is y equals x, that's my parent. So that goes like this. Oh, I should go left to right, but there it is. Now, if I remember from Algebra 1, my slope right here is 4 over 1, 4 over 1, so that means I go up 4 and to the right 1. Now, in y equals x, my slope is 1 over 1, so I go up 1 to the right 1. So up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. If I go up 4 and to the right 1, then that's a much steeper angle. And so this 4 next to the x here, if I'm multiplying by 4, then it squishes this way. It makes it taller that way. Let's say, let's do another example. And let's say this time y equals 1/3 x. So y equals x again is my parent graph. And now this one is 1/3. So 1/3, I would go up 1 to the right 3. So this time, if I go up 1 and to the right 3, up 1 to the right 3, up 1 to the right 3, then my graph looks like this. So it actually smashes it this way instead of squishing that way. Let's do another one. Y equals 2x squared. So y equals x squared is my parent graph, which is just this big U thing. Now, when I multiplied my my x over here by 4, it squishes it this way. The same thing is going to happen here. It's going to squish this way. So I'm going to have my function is going to look like this because it got squished in that way. Notice how I'm not finding any points here. Like, I'm not being super specific. I just want to understand that that's what's happening. Now, if I were to do a fraction between 0 and 1, like this one here, this 1/3 x, then it would smash it this way, and I would have something that went like this instead of in like that. Let's have you guys try one. The y equals the absolute value of, let's say, yeah, 1/3 x. All right, see what you guys can do. Go ahead and pause and do this. All right, and we are back. 1/3 x. Now, if you're ever not sure what this is going to look like, you can always do a t-table and plug in some points and get a good understanding of what this is going to look like. So if I were to plug in 0, I end up with 0, right? If I were to plug in 3, if I were to plug in 3 for x, then I would get, let's mark these out here. I want to choose numbers that are going to be easy for me. If I plug in 3 for x, 1/3 of 3 is 1. So 1, 2, 3, 1. And then let's try -3. So if I plug in -3 for x, then I end up with -1 in here, absolute value of -1, +1, 1, 2, 3, 1. And then it's just going to keep going like that. Just like that. And so, just like this one over here, it got smashed, but instead of having negative y values, I only have positive y values. So it goes back up because of the absolute value sign. All right, there we go. That looks good. Now we are going to write a whole bunch of stuff that has to do with what we just learned. And so get another piece of paper, and we are going, if you need to, and we're going to write all of this out, and that is how we're going to finish the lesson for today, 2-7. But instead of waiting for me to write it all, I'm just going to let you pause as you need to write, and I'm just going to talk through this. So we're going to make this big chart here, and we're going to label it transformations of functions. And we're going to have one column that's transformation, the next column is change to graph, and then the next one, there might be an example. Some of these will have an example, some of them don't. So make sure to write this the way that we do, the way that it's here. So the transformation here, we're going to look at translation first. So if I have f of x plus h inside the parentheses, plus h is going to move to the left, h units, that many units to the left. So for an example, I have f of absolute value of x plus 2. It's going to go to the left 2. If I have f of x minus h in parentheses, then it'll move h units to the right. So f of x minus 2 in absolute value sign, it's going to move the graph to the right. Now if I have f of x plus k, notice the k is outside of the parentheses. It moves the whole thing up k units. Likewise, same idea except for it's subtracting k, then it's going to move, the whole thing is just going to move down 2. That's a translation. The graph stays the same, it just moves from one place to another. It doesn't squish or squash or anything like that. Reflections. So now the reflection is, if the negative is outside of the function, like for instance here, f of x equals negative x squared, then it reflects in the x-axis. If the negative is inside, reflects in the y-axis. So for instance, the parentheses negative x squared, then it reflects in the y-axis, and we did an example like that. And now the dilation here. F of x, if a is not a fraction between negative 1 and 1, then it stretches vertically. It stretches vertically, or it squishes horizontally. However you want to say it, it gets taller. Now, so this is a times f of x, a times f of x. If a is a fraction between 0 and 1, then it's going to compress vertically, or it gets flatter. Okay, next. If you're multiplying inside of the function, then this is going to compress, and it's a number greater than 1. Then this is going to compress the graph horizontally, which is the same as stretching it vertically. So this is doing the same thing as this was. Notice how this is inside the parentheses, and this is outside. They're doing the same thing. Similarly, if you're multiplying by a fraction between 0 and 1, it could be, if there's a fraction greater than 1, then it would go in with this group here. But if it's between 0 and 1, 1/2, 1/3, 1/8, 7/8, something like that, then it is going to stretch horizontally, just like this one did, compressing vertically, stretching horizontally. Those are the same things. And that is all of your notes for Algebra 2, 2-7.